To start with today, let's just backtrack to a few lessons ago when we first looked at differentiation. Can you remember how to differentiate this function here from first principles? Hint, here's the formula for how to do it. Okay, well the beauty about this is that you know if you got it right because you've learned the rule, and so you are expecting to get 6x plus 7, but we need to show it. We're expected to be able to show it from first principles, not just write the answer down. Okay, that it's a proof essentially. All right, so just backtracking a little bit, what is going on with this formula? Well, we have a function y is equal to f of x, and then we've got some point where we want the instantaneous gradient, that's x, it's corresponding to f of x, just reminding you really where this formula came from. And then we choose a value of x that's a little bit bigger, x plus h, that corresponds with f of x plus h, and then we find the gradients of the chord between them. Let's just try that again. There we go. Okay, so we look at the run and we look at the rise. Okay, and that rise over run is then this bit, but then we say the point's getting closer and closer and closer to the other one, so we have to let h approach 0. Very fancy equation, very important equation. Just reminding you about it. So here I've got f of x. So f of x plus h is going to be 3x plus h squared plus 7x plus h. Okay, I need to expand this. I might do it sort of down here. X plus h squared is going to be x plus h times x plus h. That's going to give me x squared plus 2hx plus h squared if I expand my brackets. But then I need to multiply it by 3. So I'm going to get 3x squared plus 6hx plus 3h squared. And then of course I've got my 7x and I've got my 7h from before. So then f dash x is going to equal the limit as h tends to 0 of all of this stuff I'm running out of space, so actually I'm going to need to delete this diagram. Okay, and then I minus f of x, but that means I minus all of it, so I minus 3x squared, and then I minus 7x. I technically expanded this bracket here. That's all I've done. I'm dividing that all by h, and yes, these cancel, and these cancel. So next line factorize out the h. 6x plus 3h plus 7 all divided by h. Now these cancel. I let h tend to 0. That's going to mean this tends to 0, and I'm left with 6x plus 7 as I knew that would be. I've proven it using first principles. It's expected that you can do that. Hi, so today we're going to look at increasing and decreasing functions. I'll talk about what that means in a minute. First of all, I want you to have a go at this little starting question. Pause the video, go for it, do your very best. Okay, I'm going to answer it now. So, part 1, I've got that y is equal to x cubed minus 3x squared plus 4. I want to find stationary points. That means I need to look at dy by dx. By the way, this is going to be a cubic, and it's a positive cubic, and it's probably going to look a bit like this. So I can differentiate 3x squared minus 6x equals 0 for stationary points. Okay, so I can set this equal to 0. I can actually divide through by 3. That's going to be a good shout. x squared minus 2x equals 0. Factorize this, it's got a common factor of x. So x equals 0 or 2. And then y, if I put it back in, y is going to equal 4. Or if I substitute 2 back in, it'll be 8 minus 12 plus 4. It's actually going to be 0. Okay. If I've got good insight of cubics, I think this actually might be enough to determine the stationary points, because I know some points that it's going to cross at, 0 and 2, and 4 and 0. So I think it's got to end up looking like this. This is like the only possibility. Okay, because I know it's positive cubic and it comes from minus infinity. I know it comes back up. I know it then has a 0 gradient, comes back down. It's actually going to have a double root here where it just touches the axis. So straight away, I think if I have this sketch, then straight away I can write down that 0, 4 is going to be a maximum, and 2, 0 is going to be a minimum. Now let's say we're in an exam, then it's probably best to do it using the second derivative. So let's have a go at that, even though I've already done it. d2y by dx squared, we differentiate a second time, 6x minus 6, when x equals 0, d2y by dx squared equals minus 6, which is less than 0, so it's a maximum. And when x is equal to 2, d2y by dx squared is going to equal 6, which is greater than 0, which makes it a minimum. So that would be another way we could do this question. You could also look at the to the left and to the right of each point and determine it that way. Don't forget that method. I'm not going to talk about that here though. Okay, and finally, for what value does values of x does x cubed minus 3x squared plus 4 increase as x increases? Well, to answer that, this is our main topic from today. To answer that, we're first of all just going to take a little journey to this cubic over here, which I'd like you to sketch. So we know here and here, this is a different cubic, and here we've got dy by dx equal to 0. Okay, I'm not going to write it by every one, but you can see that. Now, what is going on to the graph, with the graph rather, here? Well, actually, you can see if you're a person, you'd have to climb up. You'd be increasing in height. So this is where the function is increasing, because as x increases, y increases. And the same is going on here. Okay, the opposite happens here in green. It's decreasing. As x increases, y decreases. And how can we determine these things? Well, it's to the left and right of these stationary points, but moreover, it's where the gradient is positive. It's where dy by dx is greater than 0 for increasing, and dy by dx is less than 0 where it's decreasing. And this is our entire lesson today, really. It's a chance to practice solving dy by dx sorts of problems, but bringing back in inequalities. So you can see it as revision, but it is a topic in its own right. So finally, if I want to work out where the function is increasing, okay, I just need to make a bit of space really. Okay, it's going to be where dy by dx, so number 3 is going to be where dy by dx is greater than 0. So returning to here, let's just start from the beginning again. It would be where 3x squared minus 6x is greater than 0. And I can actually divide through by 3 again. X squared minus 2x greater than 0. It's the same idea as when we were solving the quadratic. X minus 2 is greater than 0. Well, I've got the roots from before. I'm looking at dy by dx. I'm now sketching dy by dx. And I know that it goes through 0 and 2. Those are the roots. Here they are. Okay, so I'm now sketching it. It's a positive quadratic, so it's going to look a bit like this. And where is the graph greater than 0? It's this side here, and this side here. So my answer is going to be x is less than 0 or x is greater than 2. And you can actually see my cubic at the start. That was pretty good. Yeah, I drew it accurately, so you can see the functions increasing here and here, and that was equal to 2, and that was equal to 4. So there we have it. That is a first example. We'll do some more. Okay, I'll get you to practice these, but that's a first example of finding increasing functions, and decreasing would be very similar. We're going to need to solve an inequality. In this case, it's a quadratic inequality. We're going to need to be able to differentiate, but that is it. We've covered the main ideas behind increasing and decreasing functions, so have a go at these 2 questions. Pause the video and then look at my solution afterwards. So just to recap, here we are, here's the graph. We've got stationary points, we've got when the function's increasing, and we've got when the function's decreasing. So what we need to do in both cases is work out dy by dx. Let's look at the first one. Dy by dx is equal to 4 minus 2x, and then that's going to be greater than 0 for increasing. Okay, we're interested in where the gradient is positive. Then I can solve this. I'd probably add 2x to both sides and then divide through by 2, so x is less than 2. And that is all my values. There's an infinite number of values that is described by this inequality. Second question, similar sort of thing, but wait a minute, the notation's slightly different, so I'm going to use f dash x to represent the derivative, and then when I multiply by 3, that cancels out with the 3. You could, if you're still working on your differentiation, you could write this and then think, yeah, it cancels, or you can go straight to the x squared. Then it's going to be minus 2x minus 3, and the constant disappears. So this is less than 0 for decreasing. Okay, so I've got a quadratic inequality. Best thing to do is try to factorize it. And it does indeed factorize. Minus 3 and plus 1 will give you your requirements. Okay, and we're there. If you remember how to deal with quadratic inequalities, again, let's sketch the graph. That's a good shout. We know that it goes through at minus 1 and at 3. It's a positive quadratic. This time I'm interested in where it's less than 0, so it's less than 0 all the way along here. So the answer is minus 1 to 3.